So I want to welcome everybody tonight. We'll have probably a 15 to 20 minute presentation on setting up accounts, VPCs, and subnets in Amazon. I'll also answer the question over the course of the talk why I'm up here wearing a Hawaiian print shirt. I like to travel a little bit, and Amazon helps me travel, so I'll explain why. The kind of point of my talk here tonight is that Genius is taking the complex and making it simple. So I want folks to look at everything that I present tonight, but when I say something, you say, does that sound simple? Or is that as simple as possible? And if I've done my job, you'll look at accounts and VPCs and subnets and you'll say, aha, this could be very simple and it can meet my requirements. And because it's simple, it's going to provide these other benefits. So we'll explain what the other benefits are and how to keep things simple. I'm Colin Johnson. I'm a DevOps engineer and occasional developer. Professionally, the interesting thing here is I've worked at a couple ad networks. I love ad networks. These, maybe you guys don't love, these are the type of companies that like pepper your web browser with ads. I was the guy who was doing that well. So like when the ad came up really quickly, I was helping that. The guys who weren't doing this so well were the ones where the ad would like literally stop the page from loading quickly. So all the pages that had ads on from companies where I worked were very fast, guaranteed. And then some of you guys may know me from working with Lyft. When I started working with Lyft, Lyft was 9 servers, 3 cities, no auto scaling. We've got maybe half the folks here that are on Amazon, but there are going to be some folks out here who are like, I'm in Amazon, but I don't use auto scaling. I think auto scaling is the greatest thing ever. And the reason is because when I was at Lyft, we were 9 servers, 3 cities, almost no Amazon spend either. And then by the time I stopped working with Lyft, Lyft was 60 plus cities, and on New Year's Eve, 400 servers. And we had no problem with that. Literally, touch of a button. 9 servers, 27 servers, 400 servers, everything was automated. All automated with Salt, and actually, one of the fellows I worked with at Lyft, he and I contributed to the Salt project so that you can provision your Amazon infrastructure with Salt. So this is a little bit who I am. And then obviously here, this one's pretty important to me. I like to travel. So, where is this? This is Hawaii. The reason I have a picture of Hawaii in a slide deck about Amazon is because if you build your infrastructure correctly, you can go here and not worry about your infrastructure in your company. The data is going to be secure, the servers are going to be there when you get back, and you'll be on the beach. How do we get there? Here's an AWS account. AWS accounts within the account, they have VPCs, and within VPCs you have availability zones. So you have one subnet, and one subnet cannot span a availability zone. If you want to have resources in US West 2A, you need to have one subnet. This is one of the things I think is incredibly cool. This will give you a little bit of a history about Amazon. So in 2006, so roughly 9 years ago, Amazon launched its first service. This was the S3 service. This is just for storing stuff. In 2006, Amazon launched or made available their first server offering, which was the M1 Small. Nobody now is running M1 Smalls. I've launched a few because I've been working with Amazon for a little while. 2009, Amazon launches my favorite part of Amazon, which is auto scaling and load balancing. This stuff is incredibly cool. And then in 2009, Amazon announces VPC, which is the point of this talk. What's interesting about this is for 3 years, Amazon did not have VPC. And we'll talk a little bit more about what that means, but that literally means every single machine you ran on Amazon had a public IP address, which means it was potentially accessible to everybody on the internet if you misconfigured it. VPC solves this and also solves a few other problems. And the other interesting thing is, if you're an Amazon customer before 2009, you might not be in VPC. So if you're watching this talk, you may say, I want to move to VPC after hearing all the good stuff about VPC. And then lastly, maybe you're a really new Amazon customer. You don't have a choice. Amazon forced you in VPC starting December 4th, 2013. If you go right now and set up an Amazon account, you're in VPC. I think it's a great thing. There are a few customers who are like, I don't want to learn about this VPC stuff. That's why you guys are here. You can learn about the VPC stuff. Then you go back to your company and set it all up perfectly, and we can, get you go on a little vacation here. Benefits of VPC, these guys here. You can connect your existing data center. So if you want to do some sort of hybrid kind of hybrid cloud infrastructure, you can use VPC to do that with Direct Connect. You can also use VPN to do that as well. Another cool thing, you have better security because your machines can have private IP addresses. So these are the type of servers that are not accessible on the public internet. So you can build a server and be assured that people aren't going to be able to just remote right into it or like pull data off of it. So this is another benefit. You get basically better security. You can filter outbound traffic, et cetera. So there's a lot of benefits to this. So the question is, who should care about this, right? People who are moving into Amazon, people who have existing infrastructure where you're like, it doesn't seem quite right. Like whenever I do something, it takes a long time and Amazon's supposed to be fast. So maybe your VPC is not set up quite perfectly. So if you find yourself in that kind of group of people. And then lastly here, if you're examining your existing infrastructure because you think there's something a little wrong with it, why is it important? Why is it important that we get our accounts right, our VPCs right, our subnets right? Cloud needs to be elastic. So if you set your VPCs up wrong, or you set your subnets up wrong, what you're going to find out is that your cloud's not elastic. You're adding instances, and all of a sudden, you're breaking security groups. So this is a potential problem you may run into. We want cloud to be fast and flexible. In order to do that, if you do a little planning up front, you're not going to have to make any changes. You'll be able to just order additional instances from Amazon. No problems there as well. The other thing is, if you're spending a lot of time managing your infrastructure and managing your network on Amazon, you maybe are set up wrong, and your operations team is actually doing networking stuff when they could be making sure that your applications are more available. So if you spend some time up front setting up your accounts right, setting up your VPCs correctly, then your operations team is going to have time to actually help you run applications as opposed to help you manage infrastructure. I don't know if you guys have like developers who are like busy going out and like provisioning their own Amazon accounts. My feeling is if you build your Amazon infrastructure right and you make it scale and you make it fast, the developers are going to come to you and actually leverage the benefits that you can provide them as an IT organization, rather than having the development team just go run their own infrastructure, which is terrible. Developers are supposed to develop like in partnership with operations group. If they fail to, you've got developers who are developing and just building whatever they want, and you've got operations people that are maintaining maybe even the wrong things. So what I propose here is a methodology for how you should build out your Amazon infrastructure. First one, keep it simple. So this is the guiding principle of everything I'm going to tell you here. 1, keep it simple. 2, go out and gather requirements for what folks who have applications need. And then lastly, add resources to better support those requirements. If you have a particularly like onerous audit requirement, then what you might do is you might say, great, I'm going to have 2 Amazon accounts, one for production, one for QA. When audit time comes, then somebody says, well, who has access to what? And you're like, well, these 5 people have access to my production account. These 50 QA people have access to the QA account. But since all the auditors care about is the production data, I'll just say, look, there's 5 people accessing this, and that's it. It makes an audit very easy. Not the entirety of the audit. Audits can still be tricky, but that part of the audit we can take care of by having 2 accounts. Sample infrastructure requirements, if you go on like Wikipedia or something like that, you can look for these things. These are called non-functional requirements. These are all the requirements that are not application requirements. So these may be requirements for like cost. So the way you build out your accounts and the way you build out your VPCs can affect cost. It can also affect performance, security, flexibility. So what I would encourage folks to do when they're building out Amazon for the first time, or if they're looking at their existing Amazon infrastructure, is to walk through a matrix like this and make sure everything that you're doing addresses these points. All right, so why one account? The reason you want one account is, or you don't have to have one account, but the reason you would like to strive for one account is because if you have one account, you don't have to have multiple VPCs. And multiple VPCs can be a little bit of a problem. This is going to be kind of the most depth we'll get into in this talk, is explaining why multiple VPCs can be a little bit of a pain. Now, you're going to have multiple VPCs in a lot of setups, but I'll explain why, what kind of the pain points are there. And then it's just a lot easier to maintain a fewer numbers of accounts. So I see companies out there that literally have like 20 accounts. And like, great. That poor guy in operations that needs to like log in to, do some administration, he's got to keep a record of 20 accounts, or you have to hook those 20 accounts up to like a central point where like everybody can authenticate. So in my opinion, one account, or maybe you have a production account and a QA account, to keep things separate. So we'll move on to that. Why would you ever have more than one account? Well, you can do some things with cost. So let's say you have 2 Amazon accounts. What you can do with 2 Amazon accounts is, let's say you buy something that's a percentage of your Amazon spend. What you can do is your production account, you can buy that thing for the production account. And then what you can do for your other account, maybe your QA account, you care a little less about that. You don't have to buy the service for the QA account. So if you need to split things up, you can buy only what you need for your production AWS account. You could buy enterprise support, for instance, on your production account. That way, Amazon responds incredibly quickly. The other thing is, for a little while, there were capacity limits on accounts. You can imagine how frustrating this is, right? Everyone's like, hey, Amazon lets you scale incredibly, completely quickly. By the way, you can only have 100 S3 buckets. And you're like, well, I really need 120. You call Amazon up and they're like, why don't you open a second account? So there you go. If you're going to have 100 S3 buckets, this has actually been fixed. Amazon's really responsive to customers. So it used to be 100 S3 accounts. This has been fixed, but it's potentially one of those things you should be aware of. So if you think you're going to pass a capacity limit that's account-based, be aware of it. The other one, this one's pretty obvious, isolation of administration. You can have all your operations people working in your production account, and then you can just let everybody work in a sandbox Amazon account where they can do whatever they'd like. And then the other cool thing you can do here is you can isolate resources, like all your production S3 in one account and all your QA S3 in another account. That way only the right people have the right access to basically the right things. So the other reason I'm doing this talk is because sometimes moving 50 accounts down to 3 accounts can be a little tough. It's not so much that you got to move the servers from one account to another, that you can do, but you got to move the data. Moving the data is a little challenging sometimes. So why one VPC? The thing that really bothers me about having multiple VPCs is that you can't use security groups easily anymore. They become IP-based. If you've got multiple VPCs, you're going to have this problem where you have IP-based security. And what I really want people to do is get out of IP-based security. You have dynamic infrastructure, and all of a sudden you're using IPs to secure things. This is not the way you want to go, and I'll show you a slide that demonstrates that. The other reason to have fewer VPCs here is you probably don't want your operations team spending a whole bunch of time managing VPC stuff. Like, oh, you have a NAT server. Oh, you have an internet gateway. I mean, salespeople are just learning what NAT servers and gateways are, and your technical people are like, I don't want to manage another NAT server ever again in my life. Well, if you have 50 VPCs, you might have to manage 50 NAT servers. And then you literally are going to be like having an ops person manage stuff, like not applications that make you money. They're like, you know, you ever have this thing where you're like walking around and you're like, boy, I wonder what that guy's doing? Like, you know, he's an operations person like I was. And people are like, Colin, what do you do all day? And I never want to be like, dude, I manage NAT servers, because my boss is going to be like, what's a NAT server? So the way referencing security groups works is really cool. What you can do is you can say, look, I've got a load balancer here, and this set of machines right here only allows the load balancer in, and so on. So I don't have to worry about the number of machines that I run here or the number of machines I run here. All I do is I say, look, this thing allows those type of things in. You don't have to worry about IP addressing or anything like that. If you did have to worry about IP addressing, this is how it would look. This is another one of those things where people are like, what does Colin do all day? Colin manages IP lists. CTO's like, why are we managing IP lists? And I look at him like, because we didn't build Amazon right. So how does this look? What this looks like is I've got a database over here, and all of a sudden I spin up a new API server, but that API server has an IP that it's not allowed in, so I go make this change. If I used security groups and everything was connected or referenced, this would work fine. But because you're using IP security, you've got a little problem. Multiple VPCs forces you into using IP-based security. It's not fun. That's the summary. Here's another terrible example. Here we've got a rogue developer. What has he done? He's spun up a server in the IP range that I allow into my database. You don't have to be like an operations person to know this is really bad, that your developer here can access your production data. That guy right there, he's going to run a query one day against your production database that's going to take like 4 hours and bring your entire site down. I guarantee it. Like, He's going to be like, I really just wonder how many users there are in development. And he expects the answer to come back 3, right? There's only 3 users in development. Well, he runs the query against the production database, and the answer comes back like 1,600,012. And he's like, I think I did something wrong. So this is how you should be doing security. And if you have multiple VPCs, this is taken away from you. So I'm not saying don't do this, but I'm saying if you have a reason for having multiple security groups, just be aware of the impact of that decision that you're making. So why would you ever have more than one VPC? I think I've made the case here that you would want to have one VPC. So there's a soft limit on security groups. What that means is you can't have more than 100 security groups. I love security groups. I build them all the time. So this kind of broke my heart because I've had to put companies in like 2 or 3 VPCs. So if you have 10 environments with 20 security groups each, all of a sudden you're at the 200 security group limit, and you're going to have a conversation with Amazon about will they let you do this. And sometimes they'll be nice. Sometimes they'll say, you know what, we'll help you out a little. You can go to like 120 or something like that. The other things really quickly, isolation of resources. This is pretty cool. If you want to make sure that this thing can't access this other thing by default, you just build 2 VPCs, and the devices or the resources that are in those VPCs can't talk to each other. Problem solved. Pretty cool. And then you can also isolate administration so that certain people can only touch things in one VPC, and certain things can only make changes in another VPC. There's this concept here. This is not an Amazon concept, by the way, of a connectivity group, and I'll explain what this is. So there's 2 parts to this question. The first is you should have 1 subnet per availability zone. And the reason, we'll get to what availability zones are and why they're so valuable to you. And then we'll also discuss a little bit about what a connectivity group is. So here are availability zones right here, 2A, 2B, and 2C. Amazon is wonderful. It's amazing. But Amazon occasionally has outages. The good news is this. Amazon lets us know how those outages are going to happen. How do they do it? Amazon tells us that they're most likely to have outages in a single AZ. So Amazon never, ever, ever has that availability zone, and that availability zone fail. That's when you can't watch Netflix anymore, when that happens. So what Amazon wants you to do is to spread resources out through as many availability zones as possible, because there is a chance that one availability zone fails, but there's less of a chance that 2 fail at the same time. So what you want to do is you want to spread your risk over availability zones. So if Amazon makes an availability zone available to you, you use it. So at least 1 subnet per AZ that's available to you. And then the other interesting thing about subnets is you can tie them to route tables. This is going to get a little bit tricky, but I can kind of talk everybody through this. What you can do is you can say, look, this subnet right here can access the internet. This subnet right here can access the internet, but only through this thing. This is a NAT box, that evil thing I was talking about. But it prevents these machines right here from being accessible on the public internet, so improved security. And then lastly, your database over here is in a private subnet with no NAT. So what does this mean? Your database is completely protected. It's in a VPC. Nobody can access it except for those machines. Pretty cool. And then this machine right here acts as a gateway, acts as a mediator for all your requests to the internet. If you guys have worked at like really, truly, maybe not so Silicon Valley companies where they like filter the internet, this box could like do all that filtering stuff if you want. You probably wouldn't, but this is one of those things that box could do. So basically what you have is increasing security as you move over here. So what am I saying you do? You build 1 subnet for every type of connection you need. So if you need very secure data, you have 1 type of subnet. If you need public machines that are out on the public internet, then you can have a subnet for those. So that gives us this. 1 subnet per connectivity group, and then 1 subnet per availability zone. So you're going to end up with somewhere between 9 and 16 subnets, potentially more depending on what your requirements are. There's some tricks you can do to provide further security by adding additional subnets. But I really like this, particularly for small, medium-sized businesses. So in summary, here we go. Keep it simple. What does this mean? This means start with 1 account. This means start with 1 VPC. And this means start with 1 subnet per availability zone, and 1 subnet per type of connectivity required. And then you gather requirements. This can be requirements about security. This can be requirements about cost, requirements about compliance, et cetera. And then lastly, what do? Whenever you need to add complexity, meaning you need to add an additional VPC in order to accomplish something, go ahead and do it. So in final summary, if you do all this, you get to go here. So questions, I'll take them. I hope everybody enjoyed.
When you have multiple VPCs, you lose the ability to refer to security groups by their security group name. I assume that means only if you're crossing the VPC boundary. If you have two
Yes.
VPCs that do not interact, then you
That is correct.
continue. Okay.
So yeah, if you have a security group called web in one, like in one VPC, and a security group called API in the other VPC, you won't be able to use the web security group. You'll have to define the IPs, and that is it's a pretty slippery slope. I think you grabbed it already. Okay.